Hey, what's going on everyone? It's Justin Dickmeyer from engineeringtrainingexam.com, and in this video we're going to review right triangles. So what do we need to know about right triangles? Well, what we're going to learn here are two basic special right triangles and find ways, or at least define ways, we can find missing sides which we would be unable to find using the Pythagorean theorem alone. So in math and in the real world, occasionally we deal with angle measurements in the multiples of 30, 45, and 60 degrees. Because of this, there are two special right triangles that we need to take note of and at least be familiar with, so we can solve problems that come up on the exam quickly by knowing the certain characteristics of these right triangles. So the first right triangle that we need to be familiar with is the 45, 45, 90 triangle, which looks something like this, where their internal angles are 45, 45, and 90. Now in a 45, 45, 90 right triangle, say we have the sides x and y. In a 45, 45, 90 triangle, x is going to equal to y. Now the hypotenuse on the other hand is going to be the square root of 2 times either of these sides. So let's just call it x in this case since they're equal. So the hypotenuse is going to equal square root of 2 times x. So these are the two characteristics of a 45, 45, 90 triangle that you can use to determine any length of any of the sides. So let's look at a quick example here. Let's say that we're given a triangle. It's a 45, 45, 90 triangle where the internal angle right here is 45. And let's note real quick that the internal angles need to add up to 180 degrees. So if you're given an angle here of 90 degrees and an angle over here to the left of 45 degrees, you know that that third angle is going to be 45. So you can go ahead and just right off the bat know that it's a 45, 45, 90. So let's say that we're given a hypotenuse of the length 7 and we want to find the sides x and y. Well, we know x is equal to y, so let's just get rid of y here and let's just call that side x as well. And we know that the hypotenuse is square root 2 of x. And in this case, that hypotenuse is already defined as 7. So doing some quick math, we know that x is going to equal 7 divided by the square root of 2, which is also going to equal y. So x and y are equal to 7 divided by the square root of 2. Now the second special triangle that we need to know is the 30, 60, 90 triangle, and it looks something like this, where this internal angle is going to be at 30 degrees, this is going to be 60, and this is going to be 90. Now in the 30, 60, 90 triangle, the length of the hypotenuse is twice the length of the shorter leg. So let's call this x and let's call this y. So the length of the hypotenuse in this case is 2x. And the length of the longer leg is square root of 3 times the length of the shorter leg. So x is the shorter leg and y is the longer, and it's going to be square root of 3 times x. So those are the, so let's put this in a form. Let's say we have x. This is the shorter leg. That tells us if the shorter leg is equal to x, then square root 3 is going to equal the longer leg. And 2x is going to equal the hypotenuse. So again, let's look at a quick example here. Let's say that we're given a 30, 60, 90 triangle as such. internal angle here is 30 degrees, and we got 90. And once again, these internal angles need to add up to 180 degrees. So if you know one is 90, you know one is 30, that means the last one needs to be 60 degrees. So you don't necessarily need to see that every angle is a 30, 60, 90. You can just do the math and determine that that's what the triangle is. So let's say that the longer leg is equal to 12. And now the longer leg is opposite of the 60 degree angle. So let's say that our longer leg is 12 and that the hypotenuse is equal to y and the shorter leg is x. So the length of the shorter leg, like I said, is x. And since the length of the longer leg is square root of 3 times the length of the shorter leg, that means square root of 3 times x in this case is going to equal 12. So doing some quick math, we know that the shorter leg is going to be 12 divided by the square root of 3. So that's one of the legs. Now how do you find the hypotenuse? Well, now that we know x and we know the shorter leg, we know that the hypotenuse in a 30, 60, 90 triangle is just 2 times the shorter leg. So let's say y, which is the hypotenuse in this case, is 2 times 12 divided by the square root of 3. Now we can go ahead and run this through our calculator and determine what it is, but I'll just leave it at that. All I want to do is illustrate how you go about finding the lengths of the legs in both of these special triangles. So that's it for now, guys. I just wanted to go over real quick the 30, 60, 90 special triangle and the 45, 45, 90 triangle, and how you would go about finding the length of the sides without using the Pythagorean theorem. So if you guys have any more questions, go ahead and head over to engineeringtrainingexam.com. You know, shoot me some feedback on these videos. Let me know how I'm doing, if there's any special subjects that you want me to go over. Don't hesitate to contact me. I'm really here for you guys. I want to make sure that you guys are taken care of and that you're preparing just as you like, and what I want to put on the internet, what is convenient for you, what you are looking for. So go ahead and contact me through my contact form, or go ahead and sign up for the EIT Preparation Boot Camp. It's just a free preparation document that I put together to get you guys started on the right track as you head on this journey to become a certified EIT. So with that said, you guys take care, and we'll be talking soon. All right, bye.